Right now, a new technology is quietly changing how AI connects to the real world. It's called the Model Context Protocol, or MCP. Instead of building separate integrations for every AI tool, MCP creates one universal bridge between AI and software. Imagine AI instantly accessing your files, databases, apps, and tools without complicated integrations. And many experts believe MCP could become the USB-C type of AI integrations. In this video, we'll break down what MCP is, how MCP servers work, and why developers are excited about it. Today's AI tools are powerful, but they have a big limitation. Most AI systems cannot easily access external tools or data. If you want an AI model to read your files, connect to your database, or control software, developers usually have to build custom integrations for each tool. That means one integration for Slack, another for Google Drive, another for databases. This creates complex, fragile systems. And every new tool requires another integration. Clearly, this approach does not scale. This is exactly the problem MCP is trying to solve. The Model Context Protocol is a standard that allows AI models to interact with tools and data in a consistent way. Instead of building custom integrations for every tool, developers create MCP servers. These servers expose tools, data, or APIs in a format that AI models can understand. So instead of dozens of integrations, the AI only needs to understand one protocol, MCP. Think of MCP like a universal adapter for AI systems. The Model Context Protocol was introduced by Anthropic, the company behind the AI model Claude. Their goal was to create a standard way for AI models to interact with external systems. And because it's an open protocol, developers and companies can build their own MCP servers. This allows different AI models to access tools through the same standardized interface, which could dramatically simplify AI development. Now let's talk about the key component, the MCP server. An MCP server acts as a bridge between AI models and external tools. It exposes capabilities like file access, databases, APIs, developer tools, knowledge bases. When an AI model needs information or wants to perform an action, it sends a request to the MCP server. The server then connects to the relevant system and returns the result. This means AI models can safely interact with real-world systems without direct access to them. Let's break down how MCP works step by step. Step 1. An AI model receives a user request. Step 2. The AI identifies that it needs external information or tools. Step 3. It sends a request to the MCP server. Step 4. The MCP server communicates with the appropriate system. Step 5. The result is returned to the AI model. Step 6. The AI generates a final response using that information. This structured workflow allows AI models to operate much more reliably and securely. MCP servers unlock many powerful use cases. For example, developers can allow AI to query company databases. AI assistants can read project documentation. Customer support bots can access knowledge bases. And AI coding assistants can interact with developer tools like GitHub or Visual Studio Code. Instead of giving AI unrestricted access, MCP provides structured and controlled access to tools, which makes the system both powerful and secure. Developers are excited about MCP for several reasons. First, it reduces integration complexity. Instead of writing dozens of custom connectors, developers build one MCP interface. Second, it improves security. Tools and data remain behind the MCP server, while the AI only accesses approved functions. And third, it makes AI systems more modular and scalable. As more tools support MCP, AI systems become dramatically more capable. Many experts believe MCP could become a core infrastructure layer for AI applications. Just like APIs standardized how software communicates, MCP could standardize how AI interacts with tools and data. If widely adopted, MCP could enable AI systems that are deeply integrated into everyday software, from development tools to enterprise systems. And we may see an ecosystem of public and private MCP servers powering the next generation of AI applications. To summarize, the Model Context Protocol is a new standard designed to connect AI models with external tools and data. MCP servers act as the bridge between AI and real-world systems. This approach simplifies integrations, improves security, and enables powerful new AI workflows. And while MCP is still evolving, it could play a major role in how AI systems interact with software in the future. If you enjoyed this breakdown of MCP servers, consider subscribing for more videos on AI tools, emerging technologies, and the future of software development.